On this episode, in their boldest test yet, the Smash Lab team used the same type of rockets found on the space shuttle to stop a runaway truck and trailer from going over the edge. Welcome to Smash Lab, where four maverick inventors engineer outrageous new ways to make the world better. The team is Kevin Cook, the ideas guy.
Oh, that was nice!
Chuck Messer, engineer.
We will dump 800 gallons of air into this thing.
Deanne Bell, scientist.
You're going downhill, your brakes go out. What do you do?
And Nick Blair, designer.
What this actually is a 21st century booby trap.
Smash Lab. Next door to Smash Lab is Downey Studios, once home to NASA's space program.
Whoa. Oh, you're gonna like this, man. Follow me. Check her out. It's huge. This is the actual replica that was used to pitch the idea of a space shuttle to NASA.
Kevin and Chuck have an idea that's truly out of this world.
This is why we're here, Chuck. Rockets.
The shuttle is kick-started into space by two massive solid-fuel rocket boosters. Chuck and Kevin want to adapt these rockets in a whole new way. They don't want to speed things up. They want to slow things down. They have a daring concept: to use them on a truck and trailer as emergency brakes.
On the scale of crazy ideas, this one's a 10, but I'd like to see if rockets could be adapted to stop a runaway truck and trailer.
Mechanical faults such as brake failure cause more than 300,000 wrecks a year, and some of the worst involve vehicles with trailers in tow. Using cutting-edge rocket technology to prevent crashes like these is a radical idea. At Smash Lab, they explain the plan to Nick and Deanne.
You're on holiday, you've got a trailer, brakes fail, you got no other options. So, reach in, pull the little lever back, hit the big red button, fire off some rockets, brings you a nice controlled stop. Rocket brakes.
Your brakes go out, what do? I mean, it's everyone's worst fear. It's high risk, it's high reward. If we pull it off, that's sweet.
Like the scientists who developed the technology that later went on to create rockets to propel ejector seats, this idea could go on to produce a life-saving technology.
So the question on the table is, how do we use a rocket to stop a truck-trailer combination?
So rockets have a lot of power, and they're very useful. The thing is, we just need to figure out how to harness it and use it effectively.
They know rockets can send a 2,000-ton shuttle into space, but can they use smaller and safer rockets to stop a truck and trailer? To find out what a rocket is capable of, they decide to go for the burn and prepare one for launch. They head out on a road trip into the desert, deep into the desert.
It's like 30 miles of dirt roads out here. Are you sure these are legitimate directions?
Think about it. If you're going to launch a rocket, you want to be in the middle of nowhere. So I think we're going in the right direction. Nowhere.
Today's director of flight operations is rocket man Jerry Irvine. He's been making rockets for 40 years and worked on the U.S. military's Star Wars project.
All right, I think this guy here with the rocket, I think that's Jerry.
Let me just set this rocket down.
All right.
Jerry's prepared a rocket that he thinks could stop a truck and trailer.
Well, guys, this is the rocket. This is a 8-inch diameter rocket called a thumper.
This rocket looks big, but the cutting-edge technology that packs a big punch is hidden inside, the rocket motor.
Usually when you hear the word motor, you think of spinning gears and stuff like that. But when we're talking about a rocket motor's different. Essentially, it's just a casing with a bunch of rocket fuel in it.
This one is a solid fuel rocket motor, the safest and simplest type there is. It's a highly combustible fuel capable of more thrust per pound than any other solid rocket fuel. The fuel burns along a hollow central tube, pushing hot gases out of the bottom, providing the thrust. Chuck wants to measure how quickly it can deliver all its power.
Now, it looks like you have plenty of room in here and payload capacity. Do you mind if we stick an accelerometer in there to measure the G-forces, the acceleration as it takes off?
Sounds good.
The accelerometer's data should help them work out if this rocket can deliver its power quick enough to stop a truck and trailer.
Looks like we're rigging the rocket onto the launch pad. It's just about ready to go. And just be a matter of rigging up the ignition and pressing the button.
This trigger sends an electric current along the detonation cord into the motor, creating sparks that ignites the fuel, sending the rocket up.
Whoa, 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 let me have that thing.
No, 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 I don't think so. I don't think so at all. Here we go. Ready, guys? All right, I'm arming. 3, 2, 1, ignition.
The rocket climbs over half a mile up.
That is gorgeous.
Oh, it's coming down.
Getting there demanded a huge amount of force.
There we go.
Oh, beautiful.
The parachute brings the accelerometer safely back to Earth. This rocket delivered a thrust of 162 pounds over 7 seconds. It's impressive. And now they know that this solid rocket fuel packs a real punch, which is exactly what they're gonna need to stop a truck and trailer.
Well, let's get our brains moving. We need to figure out, what kind of thrust we need and how we're going to apply that thrust in order to get the whole unit to stop.
To put Smash Lab's ambitious plan into action, they'll need a baseline test to measure how much braking force it'll take to stop a runaway truck and trailer. So the Smash Lab crew are gonna run a crash scenario.
So the situation is this. You're in an SUV, you've got a trailer behind you, you're going downhill, your brakes go out. What do you do?
This vehicle is gonna tow the trailer down the hill. Oh, and it has no brakes. The only braking system it has is its engine. The driver will try to steer it onto this runoff track. Just like in a real emergency, he'll try to lose speed by downshifting through the gears. Unless he can stop it in 200 yards, he'll fly off this cliff. It's so dangerous, the vehicle is driven by remote control. In the red sports car, an operator is going to follow the truck and trailer. The team stakes out at the front of the hill beside the runaway truck ramp.
All right, this is it, guys. Car's up there. Trailer, remote controlled, ready to go.
Slow motion cameras are set up to record its speed.
All right, here we go. It's rolling now.
Okay, it's rolling.
The test rig speeds up down the hill. At the bottom, the driver turns onto the runoff ramp.
It's coming onto the dirt now.
He tries downshifting through the gears,
Out of control.
but the 2-ton trailer doesn't notice.
Into the bleachers.
Oh my goodness.
Oh, yeah, he's got it.
Oh my goodness.
Coming up, the Smash Lab crew see firsthand the results of their smash,
Imagine like if a real person was actually driving that.
and then try adapting rockets for the road.
Well, just another day at the office.